a comprehensive problem where the initial basic feasible solution is not optimal. In the earlier videos, from the earlier problems, we were discussing that the problem may be unbalanced or maximization may be my objective, or in the case of degeneracy what we'll do, and we did 3 methods of finding the initial basic solution. Here we'll go, after finding the initial basic feasible solution and checking for optimality, the Dij value happens to be negative in any of the cell, then we have to go for different iteration, in the sense that we have to go for finding a different allocation. Like this is what we're going to do here in this problem. So I have problem number 3 here, where it has depots and units, 3 depots, F1, F2 and F3, factories or depots or whatever it is, and 4 units, U1, U2, U3 and U4. The stock is given with respect to F1 is 7, with respect to F2 is 9, with respect to F3 is 18, right? Fine. The requirement is given with respect to U1 is 5, with respect to U2 is 8, with respect to U3 is 7, and with respect to U4 is 14. And if you check the total requirement and total cost, this is 334, so it is a balanced problem. And we consider this is all relating to cost, so this is a minimization problem. Yes, the standard problem is here. The first check is a standard problem. Then let me go for stage 1 to find the initial basic feasible solution using VAMS method, okay. So we'll go iteration by iteration. The first iteration here, hope you remember, we take the least value, the next least value, and subtract and put the difference for each and every row and column. So if I go here, the least value is 10 and next least is 19, so 9. Here it is 30 and 40, so 10. Here it is 8 and 20, so 12, right? With respect to column, likewise, first you have to go with respect to 19 and 40, so 21. Here 30 and 30, so directly 0. Oh, sorry, 3 and 8 and 30, sorry. So this is 22. And here 40 and 50, so 10. And here 20 and 10, so 10, right? So I have just taken the least and the next to least values and have find the difference and I have pasted it, put it on the board. Here if you check the highest penalty here is 22, so we have to focus this column, that is depot unit number U2. Choose the least element in this, so this is the least element and the requirement in unit 2 is 8, where the availability in F3 is 18, so all the units can be fulfilled here, so 8 which is 0 now and 10 remains, right? It's a usual case what we do. So no need to focus here after with U2, so let me strike it out. Then I have to do it again with respect to iteration 2. I just repeat it so that all the columns are either striked or allocated. So here is again 10 and 19, so 9. 40 and 60 now, so 20. 20 and 40 now, so it's again 20, right? Fine. With respect to columns, here I don't have any change, so directly 21. Here nothing to do with U2. What about U3 is 40 and 50, so I have 10 as a difference, and here 10 and 20, so 10 as a difference, right? And if you check the highest value, yes, it is this unit U1 which has the highest value, so I am going to focus on this unit U1, right? This unit U1, right? Fine. So checking the least value is here, 19, that is the least cost cell, 19. So all the 5 may be allocated here because 7 is the total stock available in the godown and 2 is remaining now after allocating 5 for unit 1. So this is 0, which means that you need not focus here this one hereafter. So let me go for the third iteration. Nothing to do with U1, nothing to do with U2. Now U3 is again 40 and 50, 10. U4 is again 10 and 20, 10. Let me go for the rows. 10 and 50, so 40. 40 and 60, so 20. 20 and 70, so 50. So if you check for the overall values, 50 is the highest penalty, so I'm going to focus on this F3 now, right? Depot F3. The least value here is 20 and 10 could be allocated here, so allocate all the 10 here so that it becomes 0, but the requirement is 40, only 10 is allocated, so 4 more is requirement now, 4 more is under requirement. So nothing to do with F3 because no stocks available, I strike it out. I have to go for the next allocation, fourth allocation. So here nothing to do with U1, nothing to do with U2. Yes, U3 I have 2 values which is 10 here and here it is 50, right? Fine. With respect to the fourth allocation, I have is 10 and 50, so 40. and here I have 40 and 60, so 20, nothing to do with F3, yes. So highest value, that is highest penalty is 50, which is focusing on the unit 4, so I'm just focused on this column, and the least value here is found to be 10, so 2 could be allocated, so this becomes 0 and this becomes 2 now, right? This becomes 2 now, fine. So nothing to do with F1 hereafter, so you can just strike it off this depot. And the left out values are only 40 and 50. You need not go for continuing the iteration because only 2 values are left. You can directly find the least cost value and you can allocate. So if you check here, the least cost value is 40 and 7 is under requirement, so just allocate all the 7. So 0 requirement but 2 in stock in F2, right? And see here you have 2 and 2 which will be allocated. This is why, that's why we call this is a balanced problem, right? So we have this found using VAMS method. Using VAMS method, we have found this using VAMS method. And let me have the total cost. Total cost, what we have found here, which is 19 into 5 units and 19 rupees. So 5 into 19, okay, plus 2 units and 10 rupees each. So 2 into 10 plus 7 rupees, sorry, 7 units and 40 rupees each, and 2 units and 60 rupees each, and 8 and 8, and 10 and 20. So you have to multiply and add all the figures. So if you check the value here, you have to just multiply and add all the figures. If you check the value, it is 779. Okay, rupees 779. This is not the optimal solution. We have to check the optimality. We have found the total cost using the VAMS method. Now we have to go for checking the optimality. That is, we have finished this stage. Stage 1 is done. Before checking or going for stage 2, we have to find whether there is any degeneracy in the problem. There should not be a degeneracy, which means it should be a non-degenerable problem. So we have to check for the degeneracy. So if you find here, we have how many allocations we have? 1, 2, 3, 4, 5, 6 allocations. So number of allocation is 6. There you find m plus n minus 1. So m is 3, n is 4, minus 1, yes 6. It matches. It matches. So it's a degenerable problem. That is, it's not a degenerable problem. Okay, there is no degeneracy here. So we can go for checking the optimality. So till here we have done. Till here we have done. Now we'll go for stage 2, that is to check the optimality. That is to check the optimality. Hope you remember we did in the earlier problems, problem 1 and problem 2. We'll find UIs and VJs from the occupied cells. Yes, you have these occupied cells. I have taken the table here for convenience. I had allocated for 19, so I have taken 19. I have allocated for 10, so I have taken 10 here. I have allocated for 40 and 60, yes 40 and 60 is taken here. And for 8 and 20, yes 8 and 20 I have here. So this is the table where it is occupied, the table consisting of occupied cells. Using this table I am going to find UI and VJ. So I am going to find UI and VJ, then UI plus VJ for unoccupied cells, right? And I am going to find the nature of Dij. So with the help of these tables, what I have done here will follow. So let me go for finding the UIs and VJs. UIs and VJs. Again, assume anything to be 0. Assume anything to be 0. If you just check here, I find many number of allocation in any row or column is this one for unit 4. Say I find all the cells are allocated, right? So we shall take this value as 0. So it will be easy for us to find the other values. So if this happens to be 0, this one obviously should be 10 because UI plus VJ should get the value 10. Yes, this is 10. This is 60. Yes. This is 20. Yes. Hope you know how we are finding this. If I add these values, 20 plus 0, 20. 60 plus 0, 60. 10 plus 0, 10. This is how we can find it. Let me find it for this value. For this value using 19. So 10 and 9. If I take 10 and 9, so 19. Right. Let me take for this value. I have 20 already, so I have to take minus 12. See, already we discussed in the earlier problem that UI and VJs may be positive or negative. Just some values you are assuming to find the dummy cost, right? So it can be negative or positive. No issues in finding UIs and VJs as negative here. So 20 and minus 12 give you 8. So minus 12 I have. I have to go for getting this value alone. So 60 is there, 40 is there. I have to take minus 20, right? 60 minus 20 is 40, right? So this step is over. Finding UI and VJ from the occupied cell is over. Okay, now I have to find UI plus VJ, that is UI plus VJ for unoccupied cells, So we have to add directly, and I'll post it here. So let me go row by row. Here I'm here, minus 12 and 10. You have to add, you're just adding. So minus 12 plus 10, so minus 2, right? Here minus 20 plus 10, minus 10, right? Here 9 and 60, you have to add, so 69. See, actually I'm not subtracting, there is difference and there is change of signs here, so that's why we have to subtract. So this normal addition only. 60 and minus 12, so minus 48, right? And here, sorry, plus 48, right? 60 minus 12, if you add, you'll get minus plus 48. And here this is 620 and 9, so 29. And here 20 and minus 20 is 0. Is it okay? So we have found the UIs and VJs for the occupied cells and UI plus VJs for the unoccupied cells. Now have to check the nature Dij, which is nothing but Cij minus UI plus VJ. Minus UI plus VJ, right? Fine. We'll make it here. Cij from the original table and UI plus VJ what we have found here. This is for unoccupied cells. We are going to do this for unoccupied cells. Hope it is okay. We are going to do this for unoccupied cells. So let me go for first one. Cij is 30 here. So 30 minus UI plus VJ is 2. Minus of minus 2 is plus 2. So this is 32. So no issues, positive. This is 32, no issues, positive. This one, 50 there. So I have 50 here, right? 50. And UI plus G is minus 10. So minus of minus 10 is plus 60. Yes, done, positive, no issues. Fine, next one here. For this one, F2 and U1. 70 is the Cij, original cost. Minus UI plus VJ is 69. Yes, plus 1, no issues, positive, right? Here, next column, I have 30 here, okay, 30, and I have 48, so minus 48, yes, it happens to be a negative value, so optimality is not reached. Anyway, I have to check for the other values, because when we go for not finding the optimal and when we go for the next step, we have to go comparing all the values, so it's better to check with all the values and go for the next step. So this is negative, I have to focus this step, right? Like, okay, here, this one. Here it is 40 and here it is 29. So minus 29. So this is positive. Yes, that is 11. So this is done, positive, right? No issues here. Here for this one, it is 70. Yes, 70. And you have to subtract with this value 0. Obviously this is 70 again. Positive, no issues. So my problem lies here, where I have to make this allocation to be changed. That is, I don't have allocation here, but my focus lies on this cell, which means that I have to somehow make allocation here to make the optimal solution. Now just keep in your mind, we have the total cost found using the VAMS method is 779, but after doing some changes in the allocation, let us check what happens to the total cost. So just keep it in the mind, we have the number 779, that is total cost using the VAMS method, right? Okay, now we have to go for this step. So we have Dij, we have this Dij less than 0, not optimal, so go for the next step, Please understand, the negative, why we have got the negative is not, it's feasible, that is, it's following all the constraints, but it's not optimal in the sense that there is better solution for that, so the optimality is not reached. And if you check the values written in green, that is for the occupied cells, I don't have the allocation here, okay, but my problem here is negative, the value here in this cell is negative, Dij is negative, so I had to focus on this cell so that I change the allocation somewhere and bring in a new format. Okay, so let us see what we are going to do. So I have the steps written, I will just explain the steps one by one. Select the most negative Dij cell. In here we have only one negative, so no issues. In case we have 2 or more negatives, we have to go for selecting the most negative Dij cell, not the value, the most negative. So it's always better to find the final value, right? Here it is only minus 18, so no problem, only one cell we have. We are going to form a loop with theta and minus theta at the corners. We call this loop is nothing but, I am going to form a new structure like, because the allocation is not here and from some other place I am going to bring the allocation. That's what we call as loop. Loop means somewhat a closed structure. Okay, yeah, fine. And I am going to take theta and minus theta values. Don't worry about this theta, I am going to give some value for this theta. Let us find what it is. and I have to subtract and have to repeat the steps. Okay, let me go one by one. So I have, what I'm going to do here is, please make a note. I'll just have the table. So one is here. 1 second. So I have this table where I have the allocations, right? Where I have the allocations. Just this table. Without unallocated cell, I'm going to have the allocations. So 10, 19, 10, 40, 60, 8 and 20. These are the allocated cells, right? These are the allocated cells. Here I have to bring a new allocation in this point. This is the most negative cell. Obviously here is only one negative value, so I can take this one. In case I have 2 or more negative values, go for the most negative cell. So I have to focus this one. So I'll put a star mark. I have to focus this one, right? I focus this cell. Again, what I have to do is I have to form a loop. With theta and minus theta at the corners. So in the loop, eppadi form pannona, you can form in any way, but at the corners you need to have allocation. Okay, ஒரு diagram மாதிரி இந்த மாதிரி போடலாம், இந்த மாதிரி போடலாம், இந்த மாதிரி போடலாம், இந்த மாதிரி போடலாம். Okay, or else like this. Anyway, anything you can do, but it should be in such a way that if I take the corners, there should be allocated cells. Okay, in the corners பாத்தீங்கன்னா எங்க இருக்கணும், allocated cells இருக்கணும். Okay, I have a structure which I can take it from here. Okay, I can take it from here to here to here to here. Okay, this is the only one possible, right? So if you check here, I have this column which I am focusing for allocation, this cell. Here there is an allocation, here there is an allocation, here there is an allocation, right? So corners I have allocation and here I don't have allocation, right? In the module structure, this I have taken as this model. See, here no allocation, here is an allocation, here is an allocation, here is an allocation. You can take it any way, but you should form the loop in such a manner that you have to assign theta and minus theta at the corners. So if I assign theta and minus theta, this will be theta plus, this will be minus theta, that is negative. Okay, you may ask me why you are starting with plus here, why not minus? Definitely I'll give the answer once I complete this loop. You will definitely understand why we are doing here. So theta minus theta, so plus theta minus theta. So my structure should be in such a manner. So I'll be having even number of corners. So 1, 2, 3, 4, 5, 6 corners. 1, 2, 3, 4, even number of corners. 1, 2, 3, 4, 5, 6, even number of corners. If it is odd number of corners, you will not get same, right? So I have theta minus theta plus theta minus theta. What is this theta value now? What is this theta value? Okay, why I am doing this? Definitely I'll explain. Let me go for what is this theta value. Go for the 2 cells here. This is 60 and 8. Go for the 2 cells here, 60 and 8. These are the 2 cells, right? These are the 2 cells. Now from here, I have to select the theta value, which means the least value, 2 and 8. So here I have the value 2. Here I have the value 8, right? Here it is 10. So this is 8. This is 10. This is 2, here is nothing because I have to find out. So here I have theta value 2, here I have theta value 8. I have to take the least value among these two, not with respect to theta, with respect to minus theta alone I have to take. So this minus theta is 2, this minus theta is 2. I consider this theta value the most least value, not negative, least value in minus theta allocated cells. Minus theta allocated cells. Okay, minus theta allocated cells. So minus theta is allocated in these 2 cells, right? So I have 2 and 8. The least value is 2. So I'll take this theta value to be 2. I'll take this theta value to be 2, right? Fine. Here I'll add. Here I will subtract. Add, subtract, right? What will happen now? I add here. What I'll get? I'll get 2, right? I subtract here. Already 2. It becomes 0. Right, it becomes 0 now. Here I add, it is 10, now it becomes 12, right? Now here I subtract, it is 6, now it becomes, 8, it becomes 6, right? I'm not doing anything, I'm just assigning theta and minus theta at the corners, and I take the least value between these minus theta cells and 2 and 8 were there, I have chosen 2 and have added here, subtracted here, added here, subtracted here. Why I did this now? Yes, please, I have to know this one. Why I did this now? What is the total? This is F1, F2, F3. What is the total stock available for F2 is 9, right? 9. What is the total requirement for U2? It was 8. I'm just taking from the question 8. And what is total requirement for U4 is, you can find it as 14. Okay. Earlier what we did was, this 14 was allocated here, here and here. See, we find here for 14, it's allocated 10 plus 2 plus 2. 14 you are getting, right? Fine. Now, this U4 has to get all the 14 values. How to get the 14 values here? 12 we have. Already we have 2 here. Appo 14 vandradhula add panna, right? Likewise for U2, it was total 8. So all the 8 were allocated for this from this F3, but now we are allocating only 6, which means that 2 is allocated here. This is what is called as changing the allocation so that we get the optimality. Here we allocate 2 units, which means that already there were 8 units. Another subtract pandrom. In 8 irundhathu, okay, the requirement is only 8. I had 2, okay, I have allocated this cell with 2 units. Now 2 plus 8 is 10. No, this will not match it. Transportation problem has to go with the equation or with the phrase that supply and demand should be equal. So here it is 2 and here it is 8. It becomes 10. No, it cannot be done. So I am just reducing this as 6. Is it okay? I am going to reducing this as 6. So now it is 2 plus 6, 8 done. Here it is 12 and 2, 14 done. What about F2? F2 was allocated 7 and 2. So already we had 7 here and 2. Okay. So what we are doing here is, we had 2 here, okay, 2 plus 7 is 9, but instead this 2 is shifted to this place, right? This 2 is shifted to this place, so we are having 9 here, right? So this is the method how we form the loop. See, we have selected the most negative Dij cell, right? We have formed a loop with theta and minus theta as at the corners, right? Subtract theta as the most negative theta values, yes, right? Yes. And we have to repeat step 1 to check the optimality. What is step 1? Yes. Find Uy and Vj, find Uy plus Vj, the same thing will be repeated, right? So here I have the allocation, here I have the allocation, I have written the value 19. This is a cost value, right? Here I have the allocation, I have written the value 10, right? Fine. Here I did not have the allocation. Here I have brought the loop and I have found the allocation, and this value is 30, right? So I have written 30, right? So this is done. Here I had allocation 40, so which is 7, yes, I have taken the allocation, right? And here I have no allocation, here I have the allocation which is 8, so I have taken 8. And here I have 20, I have taken 20. So if you compare this table and that table, you find here 40 is there as usual. Instead of this allocation, we have shifted the allocation here. This is what you call as forming the loop. We call this as forming the loop in independent position, because without disturbing we had to do it for this. So inga irundha allocation, this 0 maati inga maathina illaya, this is what you call as a new table. So instead of having the allocation here, I have taken the allocation here using these steps. Is it okay? Now it's the same thing, find Uy and Vj, etc. The same thing we are going to do here. So I have to find Uy and Vj. Again we have to go for assuming any one Uy and Vj is as 0. So we'll take any one 0. Anything can be taken 0. No hard and fast rule. Let me go for taking this one 0. Yes, I may take this one 0. So if this is 0, this is this is 0, this is 10, and this is 19, right? If this is 10, this has to be 10. So 10 plus 10 is 20, and this has to be minus 2. Am I right? 10 minus 2 will be 8, right? Fine. And if this is minus 2 and this is 30, this has to be 32. So 32 minus 2 will be 30, and 32 plus 8 will give you 40. Is it okay? You have found all the values for Ui's and Vj's. So if we have found it Ui's and Vj's for the occupied cells, now we have to go for finding the unoccupied cells. So this is 0 and this is minus 2. So minus 2, 0 and 8 is 8. 19 and 32 have to add, right? I think it's 51, 42, 51, yes. I'm just adding, nothing else. And here is 10 and 32, so this is 42, and this is 10 and 19, so 29, and this is 10 and 18, so 10 and 8, so 18, right? Now we'll find Dij, which is equal to Cij minus Uy plus Vj, right? Ui plus Vj. Cij from the original cost value. So let me go for the value here is 30 and let me have all the values together. 50 for the Cijs. Here it is 70. Here it is 60. The original cost. Here it is 40, I think. Yes, 40. And here it is 70. All the Cijs I have taken. I have to take Ui and Vjs. So minus of minus 2, minus 8, minus 51, minus 42, minus 29. Yes, it all happens to be positive. Yes, all is positive. This is 32 positive. This is 42 positive. This is 19 positive. This is 11 positive. This is 18 positive. And this is 52 positive. Yes, it's all positive. So the optimality is reached. Okay, we have found the optimality. We have to check the cost. So the cost here has to be taken with respect to the allocated cells. Let me have the value here. The total cost here. So total cost here is 19 into the allocation here is 5. Right, 19 into 5, that is 5 units and 19 rupees. 19 into 5 plus. So this one is done. This one with respect to 10 is 2 rupees each and 10 units. So 2 and 10. 2 rupees, 10 rupees with 2 units. And with respect to this one, we had made allocations of 2. We had made allocations with 2. So 2 into 30, right, fine. Plus, so this one is done. Here with respect to 40 is 7 units. So 7 into 40, right? Okay, fine. And next one with respect to 8, we have changed here. Either than I'm not on new values, 6 here. You should not take 8, you should say take 6. We have made the changes. So 6. So 6 into 8, right, fine, plus, and this one 20 is here, but we have made the change. It was earlier 10, now we have taken this as plus theta, so plus 12, so 12 into 10, right? So if you add all these, multiply and add all this, you have to get the value. So let me check the value here. So 5 into 19 plus 20 plus 60 plus 210 plus 48 plus 120. Yes, 743. The answer is 743, right? This is the change you find here. Hope you remember earlier we made a note of this value, which is 779, right? 779. Now we are getting the value as 743 here, 743 here, which seems this is the optimal solution. In the VAMS method use panni find panna approximate solution. This is the optimality reach panna because we had that solution was not optimal. So we made some changes in the allocation and we find the optimality, and then we find the total cost as 743. So this is your final value, right? So when you are your final student, you may expect these kind of problems. Inter-level, if your question paper happens to be a tough question paper, definitely you have to go for the steps. And be careful in attending these loopings. The loop or the allocations which I tried to change should form a loop with even number of positions. We call this as independent position because when we change the values from one place to another, like here to here, others should not get disturbed. This is what we mean this as independent solution.